Lynn, and I'm going to be going through lesson 16.2, inequalities in two variables, writing and graphing inequalities in two variables. To master this concept, I can write an inequality in two variables, I can graph an inequality in two variables, and I can interpret the graphed solution of an inequality. Also notice that our vocabulary is boundary line, solution region, and open-closed plane. Task 1, analyzing graphs of inequalities. The graph represents another plan that Dwight and Angela considered. The x-axis represents the number of terabytes of data from photos that can be uploaded each month. The y-axis represents the number of terabytes of data from text files. Identify the x-intercept and y-intercept. What do they represent in this context? So go ahead and pause the video and try A on your own. And you really want to do this so that you can learn and then come back to the video and check your answer. If you don't pause the video and you just play it through, then you're just pretty much copying down and you're not trying or thinking for yourself. So you really want to pause the video and make an attempt on your own. It's okay if you're wrong. You can always fix your answer. You learn from your mistakes. So please pause the video and do letter A and then come back to check your answer. All right, you should have done A, identify the x-intercept. So remember, x-intercept is when the line touches the x-axis or intercepts the x-axis. So right here would be our x-intercept, and that's 180 is our x value, and then 0 is our y value. So I would put 180, 0 in parentheses, and that's my x-intercept. And then what do they represent in the context? Well, let's look at the x-axis. We have photos in terabytes. So our x value is 180 terabytes of photos or photo data. Can be, and then if we go back to the verbal description, it's talking about uploaded each month. So a photo data can be uploaded each month. If, now we also need to say what that 0 represents. Well, 0 is our y value, that's text files. If 0 terabytes of text files are uploaded. All right, and then the y-intercept is where it intercepts the y-axis, and that's when x equals 0. So 0, 360 is our y-intercept. And then 0 is our x value, so 0 photos of terabytes of photos uploaded, and then we can have a maximum of 360 terabytes of text files uploaded. So 360 terabytes of text files can be uploaded each month if 0 terabytes of photos are uploaded. Think of the 5 W's, who, what, when, where, why, how. Be as specific as you can when it's asking about that context. Context, very important word. All right, B, determine the equation of the boundary, for the boundary line of the graph. Justify your response. So right now we're just writing an equation, and again, we usually always use slope-intercept form. Y equals mx plus b. Always be careful to pay attention. Right now it's asking for an equation, so we know we want an equal sign. So going back to our equation, m, we need the slope, b, the y-intercept. Now we know the y-intercept is 360, so b is 360, so we know our b value is 360. Now we need to find our slope. There's a couple ways you can do it. You can use the y2 minus y1 over x2 minus x1. You can find the rise over run. Since I have 2 points labeled on here, I'm just going to use y2 minus y1 over x2 minus x1. So this would be my x1, y1. This would be my x2, y2. So to plug that in, I would have 0 minus 360, and then 180 minus 0. That would be negative 360 divided by 180, which equals negative 2. Another way you could have done it was using the graph. So I could pick like another ordered pair here. I know my slope from 360 to 300, I'm going down 60. And then this number would be 30 because it's between 0 and 60. So then I know I'm going, my run's 30. Negative 60 divided by 30 equals negative 2. So a few ways to do that. Go ahead and pause the video, and given this information, go ahead and write the equation in slope-intercept form, and then come back. All right, so let's check your answer. Y equals, remember, we always put y equals. The y and the x, those stay y and x in the equation. We only plug in for m, slope, and b, y-intercept. Our slope was negative 2, so negative 2x. And then our y-intercept, our b value is 360 plus 360. So that's our equation for the line. Now C wants us to write a linear inequality to represent this situation, then describe the plan in your own words. So when we're writing in linear inequalities, we can keep it as slope-intercept form. We can also write it in standard form. There's lots of options, so I'm going to show you both. So let's go back to our boundary line and look at this slope-intercept form equation. Our boundary line is solid, so if it's a solid line, I know that I'm going to have either less than or equal to or greater than or equal to. So this is called our boundary line. This is where that shading ends. Like we don't have any more shading on this part of the graph. Now I also need to look for where is the shading. Well, the shading is less than that boundary line, because if my boundary line goes from 360 to 1 on the y-axis and 180 on the x-axis, it's showing all these, like on the x-axis, it's showing all the domain values less than 180, and it's showing on the y-axis all the range values less than 360. And then it has a solid boundary line. So then I know that it would be y is less than or equal to negative 2x plus 360. And then another way to write that would be using standard form. If we just rearrange this equation to ax plus by equals c, but instead of equal, we would keep our inequality. Well, I could just add 2x to both sides, and then it would be 2x plus y is less than or equal to 360. So those are both ways that we can write the inequality. And then it does say describe the plan in your own words. So go ahead and pause the video and describe what is the meaning of this in the situation, in the context again. So pause this and come back when you're done. All right, let's check your answer. So again, slope is our change in y. Remember delta y over delta x, change in x. So if we have a slope of negative 2, and we make that into a fraction over 1, that means each time my text files go down by 2, because negative 2 is talking about my y-axis, then my photo terabytes can go up by 1. So each time my text files decrease by 2 terabytes, my photo terabytes increase by 1 terabyte. And then we need to also talk about that 360. Well, when there's 0 photo terabytes added, it starts, so remember that's our starting point. So it started with 360 terabytes of text files and 0 terabytes of photos. Number 2, consider the ordered pair 90, 150. All right, and then you're going to be doing some interpretations and things like that. So go ahead and try number 2 on your own. Pause the video right now, work through 2, A, B, and C, and then come back. All right, welcome back. So ordered pair 90, 150. So let's find and label the ordered pair 90, 150 on the graph. So I know these, each tick mark is counting by 30, so they're 30, 60. This one would be 90. And then I want to go up to 150. So again, I need to look, what are they? They're counting also by 30s here. So this one would be 150. So 90, 150. And then let's label that. Anytime it says label, also write the ordered pair next to that. All right, then interpret the ordered pair within the context. Okay, again, remember we have our X value first, then our Y value in the ordered pair. So 90 is going to relate to my photos, terabytes of photos. So if 90 terabytes of photos are uploaded, and then our Y value is 150, which is our text files, then 150 terabytes of photos can be uploaded. C, does the ordered pair represent an acceptable combination of photos, terabytes, and text files in terabytes? Use mathematical evidence in the graph inequality to support your answer. So let's use the graph to check our answer. So is this in the shaded region? Going back to our vocabulary, is this a solution region? Yes, it is. So the graph supports this because 90, 150 is in the shaded solution region. Now we also want to use the inequality to prove and see if it works. So we can choose either inequality to go back to. So it's kind of up to you if you want to use your slope-intercept form one or your standard form one. I'm going to use the standard form one. So 2x, so 2 times 90 plus y, which is 150, should be less than or equal to 360. 2 times 90 is 180. And then 180 plus 150 is going to be 330 is less than or equal to 360. And that is a true statement. 330 is less than or equal to 360. So we can say the inequality supports the answer also. Number 3, consider the ordered pair 150, 90. So again, try this on your own. Try 3, A, B, and C on your own, and then come back and check your answer. All right, so 150, 90. Find and label the ordered pair 150, 90 on the graph. So 150 is my x value, which would be right here. And then this one would be 90. So 150, 90, label it. All right, so right here. Now, the next question is asking us, then interpret the ordered pair within the context. So if 150 is our x value, that means that if 150 terabytes of photos are uploaded, then 90 terabytes of text files can be uploaded. Does the ordered pair represent an acceptable combination of photos and text files? Use mathematical evidence, the graph, and the inequality to support your answer. All right, going back to the graph. Is this point in the solution region or on the solid boundary line? No, it is not. So the graph does not support that this is an acceptable combination. The graph does not support this combination because it's not in the shaded solution region. And then let's use the inequality. So just to rewrite it, it was 2x plus y is less than or equal to 360. So let's plug in this ordered pair. So we would have 2 times 150 plus 90 less than or equal to 360. 2 times 150 is 300. I already know 300 plus 90, that's 390. That is not less than or equal to 360. So the inequality does not support it either. All right, go ahead and try number 4 on your own. Pause the video and do 4, A, B, and C to check to make sure you're understanding it. Remember, it's very important that you are understanding this and able to do it on your own. All right, find and label the ordered pair 3300 on the graph, then interpret the ordered pair and see if it's a solution. So 3300. So if I go to 30 on my x, then up to 300, that's right here. 3,300, that's right on the line. So 3,300 in the context, that means if 30 terabytes of photos are uploaded, then 300 terabytes of text files can be uploaded. Does the ordered pair represent an acceptable combination of photos and text files? Again, we need to use the graph and the inequality to support the answer. Yes, it's on the line of the graph. Yes, the graph supports this combination. It's on the bound. I'm misspelling boundary line. It should be with U. It's on the boundary line, which is solid. So that includes the inequality. Then let's check with our inequality. So we would have 2 times 30 plus 300 is less than or equal to 360. 2 times 30 is 60 plus 300. 60 plus 300 is 360, less than or equal to. It is equal to. And it's solid line, so that's included in the solution. So yes, the inequality supports this. All right, let's do 5 through 7 together. How would you know whether or not an ordered pair that lies on the boundary line is a solution? Explain using connections to both the graph of linear inequality and the linear inequality itself. So this goes back with what we've talked about in previous units. If it's a solid line, it is included in the solution set. If it's a dotted or dashed line, then it's not included. And same with the inequality statement. If it has the or equal to, it's included, but if it's just less than or greater than, then it's not. So if the boundary line is solid, the ordered pair is a solution if it's on the line if the inequality has less than or equal to or greater than or equal to, then it's a solution. 6, explain why you cannot use an ordered pair that lies on a boundary line to determine on which side of the line that solution can be found. So if we're trying to figure out where that shaded solution region is, we can't tell just by using the boundary line. So you don't know if it's less than or equal to or greater than or equal to. If the line is solid, if the boundary line is solid, to be more specific, it's either less than or equal to or greater than or equal to, and your solution will be equal to each other. It's like what we got up here. We had 360 is equal to 360. So if we were trying to figure out where the shaded solution region was, we wouldn't know from just that one ordered pair if it was less than or greater than. So that's what I'm saying when I say your solution will be equal to each other, because if it's on the line, you're going to get the same number on both sides. So your solution will be equal to each other, and you still won't know if it's less than or greater than. So you'll have to use more than one ordered pair to figure that out, one that's not on the line. What piece of the inequality determines on which side of the line solutions can be found? Write your answers as two if-then conjectures. So if the inequality contains a less than or equal to symbol, then the solutions can be found below the boundary line. And if the inequality contains a greater than or equal to symbol, then the solutions can be found above the boundary line. All right, so now you need to complete the other assignments that are shown on the course calendar. So go to your vocabulary for Unit 3 packet, and then I want you to complete, since we just finished the notes on linear inequalities, I want you to go ahead and fill out the linear inequality. Remember to include examples and non-examples. Remember that your diagram or visual aid needs to be labeled. So put an example and label what different aspects of it, using vocabulary. And then after that, there is a Delta Math lesson 16.2 assignment, and there's 2 different tasks in there.
Please be at your duty stations.
All right, thank you. Have a great rest of your day.